People become scientists because they're curious.
I became an academic when I was 8.
Oh, I guess in a way it's detective work.
Multidisciplinary.
Passion. Passion, c'est la clé. Ça prend ça.
So patience and persistence.
I don't think we can tell where we'll be in 10 years.
We want to curate.
Yes, I look at dirt.
Why did I pick engineering?
Boy, it doesn't get any better than that, does it? I think if I had to describe my research in one word or two, I would say not knowing, which may sound kind of strange, but I think that not knowing is the start to being able to do really interesting things in research. There's really two main themes that I think about to my research, and one part of that is how people impact nutrient cycling, and especially nutrient cycling of phosphorus. So phosphorus is a key fertilizer that we need to grow food. And then the other half is working on ecosystem services in people. Part of what we're finding in our work in the Montérégie is that networks and connectivity of the forests has a big role to play in the way ecosystem services are provided. McGill just brings in amazing students who are really bright and really engaged and really interested in learning at the graduate and the undergraduate level. It's a special privilege to get to teach students like that. It was really an honor to be chosen to be part of the IAP Young Scientist program. We don't get a chance, I think, all that often to move out of our disciplinary worlds, but sometimes those opportunities are really eye-opening. You know, they really change your own picture of what your research is, because someone who's in neurobiology asks you a question that nobody in your field ever would, but it really sparks some new idea.
For many diseases, one of the big challenges is that diagnosis often happens only when there are symptoms. So actually in the case of breast cancer, there's actually a screening program, which is mammography. But that's inconvenient, it's actually cost intensive, you need a special technician. Some mammograms are very difficult to interpret. And so I think the hope for, not just for breast cancer, for many diseases, that we could have basically simple blood tests to do early diagnosis, for example. And that's one of our efforts then, is to try to establish a blood test for early diagnosis of breast cancer in this case, that you could then take at your doctor's office. I mean, that's kind of a long-term future thing, but that's kind of the vision where we're working towards.
Your Google search takes less than a second. To enable a search to take less than a second, you need a lot of interconnectivity between those computers. So we work at that level to enable that very fast interconnectivity between computers that work in parallel. And we use optical technology because the optical domain allows us to transmit a lot of information. La partie la plus gratifiante de ma recherche, c'est l'interaction avec les étudiants. Je trouve ça merveilleux de voir un étudiant, même avant de venir ici, mon étudiant est venu me voir avec une photo de ses résultats. Il m'a dit, regarde, ça marche. It might sound funny for an engineer in the engineering field, but there's a lot of creativity. You become an artist, a nerdy artist, but you become an artist in engineering.
So my research in general engages with the issue of how Black people were represented in Western art, both what we'd call high art and low art. So for instance, the oil painting, the marble sculpture, as well as the photograph or the print ad, okay? So how are Black people represented in Western art by mainly white artists? But I look at this historically, which means I look at it in the period of transatlantic slavery. So it involves then the issue of how Black people were a part of transatlantic slavery and what it meant to be enslaved.
You know, people who are infected by HIV very often continue to be stigmatized. We have to fight stigmatization. We have to insist that people who are infected by HIV are recognized as having all of the human rights that the rest of us enjoy. And at the same time, we have to really work hard to ensure that drug access for all, and by all I mean people living in developing country settings, is a reality.
So how can we create tools within our societies to make sure that migrants, even irregular migrants, have their rights recognized? I write reports for the Human Rights Council. These reports from the 52, 53 mandates that exist are accumulated. They are accessible online. Everyone can read them, and they're used by NGOs in their dealings with their authorities. In a typical country visit, I will meet the minister responsible for immigration, I will meet employers, I will meet NGO working with migrants, and I will visit detention centers where migrants are detained.
I've been very lucky because I was trained as a historian. Quite often historians have one period that they sort of stick to forever. But just as I was leaving university and going to graduate school, I discovered social science. So I ask social science questions about historical materials, and I sometimes find that social science doesn't have enough history, so I go back and forth. But it means I've been able to change the subjects that I've done at various times. So I've written a great deal about states, state formation, both in the past and more recently, and quite a lot in recent years about nationalism and the fall of empires.
About 8 years ago, I became Associate Dean of Science, academic. And as part of that job, I sit around talking to people in the different departments in science a lot, including the chairs. And often they would ask me what I do, and I said, well, I'm a compiler developer. And they say, oh, well, that's very nice. What languages? And I would say, oh, Java, Aspect-J, and then they weren't at all interested. And that actually got me thinking, okay, what are the languages that the scientists and the engineers are using, and what are we doing to help them on the compiler front? And that's really how I started working on the language MATLAB, because that's what they're using. I think it's important for more computer scientists to become fellows of the Royal Society, because as a new discipline, it's underrepresented. So it's very good that there are more computer scientists, and they can help shape the future of the society and the direction of science in Canada.
All of my research has been devoted to Canadian literature, the history of Canadian literature, the teaching of Canadian literature, the way in which Canadian literature has been manufactured, disseminated, published, the way in which government infrastructures interact with the production of Canadian literature. So really, I guess if you had to put it in a nutshell, I'd say that my main concern is with literary value in Canada and the way it has been constructed, the forces that have contributed to the evolution of value in Canadian literature, and the way in which Canadian literature has been received by the public, really over the last 2 centuries.
At about 20 nanometers.
What we do is we make these very simple molecules that we have encoded, and they make a structure. So a simple molecule might make a rod, or it might make a square or a cube on a molecular level. We then use those structures to grow another structure. So it's a little bit like we're making muffin tins, and then we grow something in those muffin tins. Those things that we grow are nanomaterials, and we apply those to many applications in biological sciences, physical sciences, neurosciences. We have a tremendous responsibility to reinvent those processes so that they are as pollution-free or as pollution benign as possible. So that's a personal aspect. My research impacts or talks to the green agenda because our nanomaterials, in some instances, are very powerful entries into doing green chemistry.
So my research is in the field of green chemistry, which is trying to develop and invent a new chemistry where we can make chemical products easier, cheaper, simpler, cleaner, and more sustainable. One example is we're studying ways to develop new chemistry where we can convert a biomass such as sugar, lignin, and cellulose, and other things available in nature to turn them into useful products.
I look at dirt. I mean, people call it soils, but it really is dirt. And I look at the way in which soils both are affected by the environment, for example, the climate or the vegetation patterns or the underlying geology, but also the way in which the soils in turn mitigate environmental change, how they can be, for example, used perhaps to stop climate change in terms of global warming.
In today's 7 billion world, the food production and availability of food to the population is one of the main concerns. So I work in terms of enhancement of heat and mass transfer applicable to biological systems to conserve food. That's one of the key aspects. And then also the membrane technology, how we can keep food longer. And I'm fortunate to be connected very much with Asia as well as North-South like Brazil, and also now more with African countries.
Notre travail, en fait, focus sur trouver ou investiguer pourquoi les personnes, en général, souffrent de maladies cardiovasculaires ou de maladies cardiaques. Donc, on veut chercher quels sont les facteurs qui font que les personnes, les femmes, les hommes, sont plus à risque de maladies cardiaques. Pourquoi les personnes meurent d'une crise de cœur? Pourquoi d'autres personnes n'en meurent pas? Donc, on cherche sur quoi on peut intervenir pour améliorer leur pronostic puis faire en sorte que ces personnes-là, finalement, ne souffrent pas de maladies cardiaques ou en tout cas en meurent pas. Receiving the Alice Wilson Award from the Royal Society of Canada was, first of all, really an honor. Like a little tap dans le dos to tell you, you know, keep going, you're doing a great job. Right at the beginning of your career, it's amazing.
The focus of my research is the genetics of aging. So what we're trying to do is to study mutants that are either long-lived or short-lived, and by understanding how they achieve long or short life, to understand basic principles of why organisms age and what's happening during aging. So we're studying these animals, finding out how the gene is modified, and manipulating the gene to understand how the change of gene X is actually bringing about a physiological change that allows long lifespan. Doing this research, I would have done on my own dime if I had the money. Therefore, I have just managed my entire life to do that, what I wanted to do anyways.
Le fil conducteur de ma recherche, c'est vraiment un intérêt pour la biologie des changements climatiques, c'est-à-dire de quelle façon les changements dans la concentration de carbone dans l'atmosphère et les changements de température affectent la biosphère. Mais dans mon cas, c'est surtout les plantes. Alors, dans les années plus récemment, j'ai travaillé beaucoup sur la forêt tropicale. Et ce qui m'intéresse, c'est de voir de quelle façon on peut ralentir le déboisement dans les tropiques et se servir de ça comme une forme d'atténuation pour les changements climatiques. Alors, la recherche de mon groupe d'étudiants porte tout autant sur les mesures du carbone de la forêt tropicale comme sur les façons dont on peut appuyer les communautés et les gouvernements des pays en voie de développement pour réduire le déboisement.
So one of the things we do as physicists is we try to understand all the extremes that matter can be put to. So there are people who study what happens when you reach the coldest cold temperatures that we can achieve. And I'm on the opposite end, we're trying to understand what happens when you reach the hottest hot temperatures that can be achieved. Well, right now we're actually in a very good position in my field of research because we have a large new experiment which is just turned on, which is the Large Hadron Collider at CERN. And since they can achieve a higher energy and since they have more sophisticated and comprehensive detectors, then they're in a position to tell us a lot of things that we couldn't have learned with the existing facilities. And that program is just at the beginning. So I'm expecting that next 10 years there should be a lot of fresh, good new data, pushing us in new directions, giving us something to try to understand.
I study the brain and how the brain controls our cognitive, our mind processes. A large part of my research has been involved with what we call working memory, which is really the ability to hold on in the mind a few items, a few thoughts, and then juggle them, monitor them, rearrange them. We've localized a specific part of the prefrontal cortex, right at the very front of the brain. And more recently, we have shown that it interacts with some other parts of the brain more posteriorly in the parietal lobe, which are playing a primary role in the rearrangement of our thought processes.
I work in computational fluid dynamics, which essentially is the calculation using large supercomputers of fluid flow, gas flow, over aerodynamic objects like an airplane, a helicopter, or a jet engine. And that helps us through the calculations to design better components for these. Specifically these days I'm working on in-flight icing, which is the science of predicting what the ice shapes are going to be on airplanes when they traverse the clouds, whether during takeoff or landing, and helping the aerospace industry then figure out best ways to increase safety for flying into known icing.
Well, I sort of say I'd look at areas where there are no answers. That sort of wakes people up or makes them take another drink. And then they ask what areas, and then I will say, well, any new developments in science in relation to human persons and their values, their future, how they see themselves in society, and what hopes they have for their children. And they still don't get it. And they say, are you a physician? And I say, no, and I'm a law professor interested in how law can be a tool for social reform and reflect the hopes that people have in science in terms of what it can do for themselves, their families, the environment. And the most exciting part is working with people who come from other backgrounds, like not only genetics and genomics, but political science, bioinformatics, reproductive technologies, endocrinology, and so on. So I'm constantly learning. It's like being in a postdoc forever.
From the beginning of my career, I've always been interested in public legal education and access to justice. How well the formal legal system serves the needs of all citizens, and not just the well-off, not just corporations, not just institutions. I think in the last 10 years, I've become much more interested in legal education. How it is that we train aspiring lawyers, what are the fields that we focus on, how much time do we spend on basic issues of client service, ethical practice, pro bono work, what it means to be a virtuous lawyer in today's climate. And I think that will probably be my prime focus of research for the rest of my career.